Hey Gr9s, so this lesson is really important because you're going to be doing a lot of naming compounds this year, or you'll be given compounds and you'll have to be able to determine what elements they're made from, and it'll also help you a lot for chemistry next year. So for grade 9 there are two types of compounds. We have compounds made up of, there's actually three, so we've got compounds made up of a metal and a non-metal. And we've got compounds that are made up of non-metals only, so a non-metal plus a non-metal. And then you also get metals, but we're not really going to do those this year. That'll be for next year. Those we call alloys. And they're not really compounds, they're actually mixtures. Mixture of metals. Melt two metals together, and when they cool and solidify, the new compound, the new product that you form is actually just a mixture of metals. The metal and the non-metal, we call that ionic. And a non-metal, we call that covalent. Okay, so those are the two cases that you're going to be dealing with this year, ionic and covalent. Okay, so each element's got a unique name, and this is also true for compounds. So each compound's got its own special name. The same elements can build very different compounds. For example, if you take two hydrogen atoms and you join them to two oxygen atoms instead of one, you'd end up not with water, remember the formula for water, H2O, but you'd then have H2O2. And H2O2 is a very different compound called hydrogen peroxide. So I'd happily drink water with the formula H2O. So we've got, for water, we've got one hydrogen on this side, one hydrogen on that side, and just one oxygen. So H2O. You could represent it by doing this. The lines represent bonds, chemical bonds. So there's oxygen bonded to hydrogen and hydrogen, whereas hydrogen peroxide is something very different. Here we've got oxygen and another oxygen and a hydrogen and a hydrogen. There's bonds between them. So here's what that would look like. H bonded to oxygen, bonded to oxygen, bonded to hydrogen. And hydrogen peroxide is a really dangerous compound. Used to bleach your hair, not to drink, whereas water is quite safe to drink. So even though both compounds have got made up of hydrogen and oxygen, the ratio that the elements are combined in is very different, and that has an effect on the properties of the material and also its name. So water versus hydrogen peroxide. Another example, carbon monoxide and carbon dioxide. We breathe out carbon dioxide and eventually it could suffocate you, but it's not nearly as toxic as carbon monoxide, which is a much more dangerous compound. So although carbon monoxide and carbon dioxide have both got carbon and oxygen, we'll have the red atom representing oxygen and the grey representing carbon. So on the left, carbon monoxide, mono means one. We've got one oxygen, whereas carbon dioxide, di means two. So although carbon monoxide and carbon dioxide have both got elements, carbon and oxygen, the number of atoms differs. The ratio in which those elements are combined is different. So why is it important to distinguish between the two compounds if they have the same elements? Well, because although the two compounds consist of the same elements, the ratio of the elements is different, and so the properties of the compounds will also be different. So like I said, we breathe out CO2, but carbon monoxide, CO, is an extremely poisonous gas. So although these two compounds consist of the same type of elements, by the same type of elements, I'm meaning carbon and oxygen. The ratio, the important word is the ratio in which these elements are combined. Okay, so like I said, for example, we breathe out CO2, but CO is a poisonous gas. We exhale CO2, but CO, so we exhale carbon dioxide, but carbon monoxide is a poisonous gas. Right, so by ratio, here we've got a 1-to-1 ratio for carbon to oxygen, whereas here for carbon, we've got a 1:2 ratio. For carbon is to oxygen, carbon is to oxygen. So 1 carbon, 2 oxygens, whereas here we've got 1 carbon, 1 oxygen. That's what I'm meaning by the ratio. Okay. I spoke about the atomic number and atomic mass. Remember, atomic mass is made up of protons plus neutrons, whereas atomic number is protons only. And if you want to work out the neutrons, it's equal to mass number so the mass number minus the proton number. Mass number minus proton number will give you number of neutrons. Right, so rules for naming compounds. Like I said, there's the 3 types. We're only going to be dealing with the 2, ionic and covalent. I said ionic is if you've got a metal and a non-metal. So we call that ionic. The metal comes first and then the non-metal second. So really important, highlight that. Metal first, non-metal second. The name of the non-metal changes slightly though. We add the suffix. A suffix is something that goes at the end of the name. We add the suffix "ide," and that replaces the ending of the name. So highlight that part. So for example, you're familiar with table salt, sodium chloride. So sodium is the metal. Have a look where sodium is on the periodic table. This group 1, is the alkali metals, and here's sodium. So sodium is the metal, and chlorine is the non-metal. Chlorine's on the right-hand side of the step line on the periodic table. There's chlorine, so we've got metal, non-metal. It's an ionic compound. So we've got sodium, metal, and chlorine's the gas, which is a non-metal. And the gas is a non-metal, so the ending of that element, the chlorine's element name, changes. So instead of saying chlorine, we replace it with an "ide." So sodium, sodium chloride. Okay, and it's as easy as that. So let's look at some examples. If you've got an element with iron and sulfur will give us iron sulfide. All of these are metals. Iron, magnesium, sodium, and so on, they're all metals. Magnesium is a metal, nitrogen is a non-metal. So all of these then would be ionic. Metal, non-metal. So the compound would be an ionic compound. And so magnesium and nitrogen gives you magnesium nitride. Sodium and chlorine we've done. Tin and oxygen would give you tin oxide. And like I said, notice how you replace, instead of nitrogen, you replace the end part with an "ide," IDE. Okay, lithium and nitrogen, lithium nitride. Zinc and sulfur, zinc sulfide, and so on. So for type 2 compounds, that's when you've only got nonmetals. And I told you that those would then form covalent compounds. Rule 1. The name of the element further to the left comes first, and that's followed by the name of the element to the right. The name of the second element changes slightly. Again, we add the suffix "ide" to replace the ending of the name. Rule 2. When 2 or more compounds have different numbers of the same element, like carbon monoxide and carbon dioxide, we add prefixes to avoid confusion. So rule 1 is quite similar to the first one that you had to ionic compounds, whereas here we do add prefixes. So please highlight that. Add prefixes. And you add the suffix "ide," and whatever's on the left comes first. So let's find carbon monoxide. So carbon is here, oxygen is here, so carbon is the one on the left. So carbon comes first. You don't have oxygen carbide or oxygen dioxygen carbide. You don't speak of that. So you're already familiar with carbon dioxide. Let that be the default one. Just like sodium chloride you're already familiar with. So sodium chloride, sodium's the metal. Metal comes first in ionic compounds. In covalent compounds, think carbon dioxide. Carbon comes first because it's on the left. And carbon dioxide, the prefix di is what you have to add. So let's write that down. There we go, there's your prefix. The di is your prefix. So covalent compounds do get prefixes. So they all get the I, but covalent gets a prefix, whereas ionic, no prefix. You don't speak of sodium monochloride, it's just sodium chloride. Okay, so there are some prefixes that you need to know. Number of atoms, 1, 2, 3, 4, 5. The prefixes go mono, di, tri. I mean, like a tricycle has got 3 wheels. Tetra, a creature with 4 legs, like a cat or a dog, you can say is a tetrapod because it's got 4 legs. And like the pentagon in America has got, or a pentagon shape has got 5 sides. And these prefixes you do need to know. Another one that I would add is hexa, which is 6. Okay, and there's an example in one of your exercises that's got a hexa. So when we're talking about the prefixes, these are the prefixes. So di, tri, mono, tetra, penta, and so on. Okay. An example, so nitrogen dioxide would be NO2. Whereas carbon monoxide, there is an invisible 1 there, so you don't write it, but there is in fact a 1 because of the mono meaning 1. Di means 2, and that's why we've got the 2 by the nitrogen. Sulfur trioxide would be SO3. Carbon tetrachloride would be CCl4. Phosphorus pentabromide, PBr, and penta means 5. Okay, now we've got another rule. Many compounds are not usually referred to by their systematic names. Instead, they've got common names that are widely known. So, for example, dihydrogen monoxide. Let's think of this. So di means 2. So we've got 2 hydrogens and 1 oxygen. And I hope you recognize that formula for dihydrogen monoxide as being the formula for water. Its chemical name could also just be dihydrogen oxide. Chemical formula H2O, and we know that commonly as water. Ammonia, the formula you should know already is NH3 from last year. And the formula then would be nitrogen trihydride, so 1 nitrogen, 3 hydrogens. So this prefix tri, it just means that we've got 3 of the hydrogen. Methane is the common name for the chemical carbon tetrahydride. Tetra meaning 4, hydride, 4 hydrogens, and 1 carbon. So there we go, CH4. Chloroform, the formula is CHCl3. So the name for that would be trichloromethane. And that comes from methane, which is CH4. And so instead of having CH4, you replace three of the hydrogens, with a chlorine. How do you know these? You don't. You learn them. So this table you just have to learn, just like these prefixes you would have had to have learned, and the rules you have to learn. Alright, so now let's test your knowledge. Let's do some together. So we've got NABR, they are ionic. So we do not have prefixes for ionic compounds. So just sodium bromide, not sodium monobromide. The next one, we've got calcium, oxygen, so calcium. Even though you might want to say calcium monoxide, it's not calcium monoxide because these are ionic compounds and no prefix. Over here we've got two lithiums, but because it's ionic you do not need to say dilithium, just lithium. And then sulfide. We do accept sulfur spelled PH or F, so you could have sulfur spelled with an F. There are two conventions depending on if you're going by the American system or the British system. Both are acceptable. So because you've got ionic compounds, remember that's metal plus non-metal. If I gave you these names and I said write the formulas, remember that the metal comes first. So I'll highlight the metals in blue. Sodium's a metal, calcium's a metal, lithium's a metal, so that's why the metals come first. And the non-metal would be bromide, oxide, sulfide. So because you've got metal, non-metal, you're going to follow the first rule and you do not have a prefix. You replace the last bit of the second name, so bromine becomes bromide. Oxygen becomes oxide, sulfur becomes sulfide. See if you can do magnesium on your own. And now these are covalent compounds. So covalent compounds is just metal, non-metal, and non-metal. So non-metal bonded to a non-metal. Okay. And with that rule, we do use a prefix. So here we've got sulfur and two oxygens. So because we've got two oxygens, we're going to have a dioxide. Number 10 should be really easy for you. I'll do number 8 with you and you can do the rest. So B is for boron and F is for fluorine, so we're going to have a fluoride. Replace the fluorine with the fluoride, and because we've got 3 of them, we're going to have a tri over here. So boron trifluoride, without a space though. So boron trifluoride. Okay. The rest is for you to do, and we will start with chemical reactions as a separate video in your next lesson. We'll also mark question 4 and from this section the ones that haven't been done. So please make sure you do those on your own for homework. Thanks, Gr9s. Bye.